Okay, so here we have another initial value problem, and so the equation we start off with is x dy over dx minus y is equal to 2x squared y, and this is our initial value condition. So like anything else, we want to get the x's on one side, and we want to get our y's on the other side. So then you add y to this side. You factor out the y, you make it one singular y. Makes it easy to work with. I mean, anytime you have two y's, just try to make it so you have only one y. It's a lot easier. So you put it into an argumentation like this, then you factor out a y. Now you're dealing with just one y. And now, obviously, you just divide this side by y, and then you divide this side by x, and you're left with the integral of 1 over y, because we divided y from this side, dy. And because we it's dy because this is a y, sorry, right over here, this is a y. It's a dy because we multiplied the dx to the right side. So then this side is, remember, we divided by x and we divided by y. So we got 1 over y on this side, we would get 1 over x on this side, but because we have something, we could just multiply this times the 1 and we'll be left with 2x squared plus 1 over x and the integral of it. So now we could rewrite this as, let's rewrite the equation. Now, what you could do here is cancel out an x, but to do that, you have to rewrite, you could separate the fraction. So instead, you can make it 2x squared over x plus 1 over x. And this allows you to, because if it's in this form, you can't just cross out an x, right? You just can't do that. Because you have to do it here too, but there's nothing here. But because we can separate the fractions, this would have had an x under it. This actually would have been 2x squared over x. But because we're getting rid of an x, we can just write 2x over here. X squared, there's 2, you cancel out, you're just left with 1x, 2x. Plus 1 over x, because we separated the fraction. Now, the integral of 1 over y is log, natural log of the absolute value of y is equal to, so this side, we take the integration of 2x, you're just going to get x squared. Because there's a 1 over here, you add 2 to it, or you add 1 to it. So there's an invisible exponent of 1, you add another 1 to it, then you would get 2, then you divide by the exponent, so you divide by 2, 2's cancel out, you're left with x squared, plus 1 over x, and you take the log of it, same like you did 1 over y, but this side, it'll be the log of, natural log of the absolute value of x, so similar things, plus our constant, of course, of integration. So now to get rid of the logarithm, one really cool trick you can do on this side is just put everything up to e. Because remember, if you make everything on the right an exponential, it cancels out the logarithm. That's the relationship between a logarithm and an exponential, is that they cancel each other out and that they have a relationship that you can use to manipulate your equations. It's kind of cool. So if you have a logarithm on this side, you just put this entire equation up to e. Now, the reason I have it equal to this is because this is what it would look like, right? So this entire side, x squared log x plus constant, x squared log x plus constant. If you put an exponential in e, and then raise all this to the power of it, you would get rid of the logarithm on this side, which is exactly what we're trying to do. But here what I did was I separated it into 3 different pieces. And I'll explain why there's a cross here. I separated this side into 3 different pieces because you can do that, because remember, when you multiply variables, the exponents add, right? So you could use that backwards. If the exponents are already added, maybe you could turn it into a form where you would have to multiply them. And that's exactly what you have over here. So you get e to the c1, because this is no particular order, I just changed the order because it's easier to deal with. E to the c1, e to the x squared, and you get e to the log x. Now, I cancel this out because anytime you have e to the log of something, so e raised to the log of something, you can just cancel out the log and the e. And you'll just be left with the absolute value of x. So now you're just left with e to the c1 on this side. Don't worry about the plus and minus. I'll explain that in a second. So you're left with e to the c1 times e to the x squared times x. Now that's what you would be left with, right? But here what we could do is, to get rid of the absolute value, we just want y as it is. We don't want the absolute value. And remember, absolute value, to just cancel that out, to get rid of the absolute value, you could just say that the equation on the right is either positive or negative, right? It's plus minus. And so we get plus minus e to the c1. Now, really cool, since this is all just going to be a constant, you're not going to get a variable out of this. Remember, e is just a number, right? So you're just going to get a constant out of this. So what you could do is you could just set plus minus e to the c1 equal to just a big C. And here, that's what you get. Now, you simplify it, and it's just beautiful. It's so consistent and just concise and small, and that's what you want, honestly. Like, whatever you could do to shorten your equation, that's what you should be doing. So plus minus e to the c1, just turn it into a c, and you're good to go. Now, plug in the initial value. So here, what we got to do is plug in the initial value. So y of 1 is equal to 1. So since y is 1, we just set this equal to 1. X is also 1. So everywhere we see a 1, we just put a 1. Or an x, sorry, we just put a 1. So it would be y, which was equal to 1, of x of 1. So y of 1. So this is a 1, this is a 1. So this over here is a 1, which is why we have e to the 1. And this x is a 1, which is why we have 1. You're left with 1 is equal to the c times e, because this is just e. And, 1 is just 1, so ce. And we solve for c, and you just divide both sides by e. And we have 1 over e is equal to c. Now, you just rewrite the final. You replace the c over here that we put as this plus minus e to the c1. You replace it with the answer you got here, and now you're left with y is equal to 1 over e times x to the times x times ex squared. And think about how cool that is. I mean, by just turning this into a constant, you were able to solve for it, plug it back in. Now we don't have a problem anymore. Like, it's kind of crazy how that works, so it's really cool.